start on function of 3 variable. Okay. So what is W equals to f x y z? So f is a real value function of 3 variables, or simply function of 3 variables. So W is dependent variable. W will depend on x, y, and z, and x, y, z are the independent variables. Okay. Okay, I think you already know this. X plus y plus z. So if f negative 1, 2, 3 means negative 1 plus 2 plus 3. F 0 negative 3, 1 means 0 negative 3, 1. 0 minus 3 plus 1. So 0 minus 3 plus 1 will be
minus 3.
Yeah, so minus 3. You should please amend on your notes. This is minus 2. Okay, negative 1 plus 2, 1. 1 plus 3, 4. Correct. So RST, RS, R plus S plus T. Okay. Okay. Then on negative 1, 2, 3 means negative 1 squared, 2 squared, 3 squared. 1 plus 4 plus 9 will be 14. 1, 0 plus 9 plus 1 will be 10. Okay. Okay, domain and range. Domain and range. Okay. As usual, domain set of all inputs. Range will be set of output that result when the x, y, z varies over domain B. Okay, we see here, determine the domain and the range. Okay, is the domain correct? What do you feel? Is this correct? Can anyone share their opinion? For function square root x squared plus y squared plus z squared, is the domain x squared plus y squared plus z squared more than equal to 0?
Yes.
No, this is wrong. Okay?
Wrong.
Yeah. Why?
Because power 2.
Because of?
Because
square root 0 equal to 0.
Okay. That's all. So because we can put any values of x, y, and z. Okay. So the domain for the function square root x squared plus y squared plus z squared will be R, or negative infinity to infinity. The domain. Okay. Then the range is W more than 0. Okay. Why? X squared plus y squared plus z squared. The minimum value for x, y, z will be 0. If I put 1 here or 0, 0 here, will be 1. So the square root also cannot be negative. So it will be 0 and to infinity. So the is 0 to infinity. Or you can write as W more than or equals to 0. Okay. Example 2. Okay. Now for this, we have 1 here. Okay. So for the domain, as usual, inside the square root, you have to make inequality more than or equals to 0, or you can write as less than 1. Okay, just bring the right and to the left. So this is your domain. Something wrong here. Check. Okay, that's that. So the domain will be, you can write directly like this. Something wrong. Let me check my Twitter. This is your domain. This is your domain. And your range. You have to see what is the maximum value of this. Of course, 0. And the minimum value of this function, x squared, y squared, z squared will be 0. And the maximum will be 1. Why? We follow this. Okay, we borrow the domain's restriction to get the range. So if I put this all 0, so you have square root 1, that is 1. If I substitute this with 1, you will get square root 1 minus 1, which is 0. So your range will be 0 to 1 included. Okay. This is easy. If you see something like this, the domain will be x plus y plus z not equals to 0. The denominator cannot be 0. How about the range? Okay. If I put everything 0 here, which means undefined, right? But 1 over 0 is what? Is it infinity? Infinity is not included, as we know. But how about if I put 1 over infinity plus infinity plus infinity? So you will get 1 over infinity that approaches to 0, also not included, because it will not touch 0, but it is approaches 0, which means the range will be 1 over infinity or 1 over 0, which is 0, infinity. So, but the x can be negative, can be positive. Y also can be negative, can be positive. Z also can be negative, positive. But not all 0, which means your range is not 0. Everything but not 0. You can write like this. Union with 0 to infinity. Okay. Is this? There will be union. Okay. Together. Okay. Negative 20 to 0. Or simply W not to 0. Easy. Okay. Just let this with W. Okay. Any question? Any question?
No.
Okay.
Yes.
Doctor?
Yes. Yes. Stop.
Sorry. Can you please explain how do you do the number 1?
Which one? This.
The example first, how do you do it?
This.
Yeah. For domain and range.
Okay. For this,
Yes.
we can put a domain is set of possible input. So we can put any values of here. Inside the X, inside the Y, inside Z. So the domain will be R. Negative infinity to infinity. Okay? Who is that?
Me.
What is
Answer.
it? What is your name?
How about the range, doctor? The range?
Okay, what is your name?
The range?
No, your name. Your name.
Sorry, Zuhai.
Zuhai. Okay, Zuhai.
Sorry. Zuhai.
Zuhai, okay. What is the other question?
Yes.
Range, is it?
How do you do the range for the range?
For the
Yes.
range, you have to see as a whole, included
For the
square
range.
root. For the range, you have to see include the square root. Okay, for the domain, you have to see the restriction. But now, because all are squares, the domain will be negative infinity to infinity. Okay, about the range, you have to see included the square root. So when I see here, when I include the square root, inside, you have to see the maximum and the minimum value. So the maximum value of this can be anything, right? 1, 2, 3, 4, 5, 6. If I put negative, you just negative 5 to 5. Okay. If I put negative 5, it become positive. So there is no possible to get negative answer inside the square root. So positive infinity is there, confirm. What about 0? If I put 0, 0, 0, so the minimum value will be 0. So the range will be square root 0 will be 0. Square root infinity will be infinity. So, yeah. No.
Yeah.
Understand. Thank you.
Doctor, I'm sorry, sis, I don't have earphone. I can't hear your voice clearly. Hey, can everyone hear my voice? Is it clear?
Your voice is
Yes.
quite soft, Doctor, without the earphones.
We can see.
Increase your volume.
You want me to increase my volume?
No, for the student, increase
Oh,
the
okay.
volume
Yeah.
of the device.
Check. May check my microphone. Is it okay? I think my microphone should be okay. Okay. So, okay, next. Okay. So we have some activities here. Divide a paper into 2 sections. Important, right? One is important, one is blur. This is list important details what covered by lecture by today. Blur, please write topic that is still blur, right? Discussion. Okay. What you have to do is, I think I give you Padlet, right? Section 44. Okay, let me best and blur. Okay, let me write. Okay, best. I think another one should be blur. Blur. Okay, I don't know. Can you comment on this, my comment? My post, share first with you. Okay, try to open the Padlet. Okay. 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 So try to comment what is the best and what is the blur, whatever you learn in chapter 1 part 1. I mean important and blur, okay? Important. So I just use the word important. Please comment here in my comment, in my post only. Okay? Don't like here. I can say this is important. Okay, please write what is the best and what is blur. Okay, so everyone please do it. I will check. Range, okay, range is difficult. I identify the range is a little bit difficult, but by practice, if you see, if you do a lot of question, and then whatever you do, please you can refer to move from alpha, okay, except for your test or final. So for practice, you can use the move from alpha to check. Let's say square root square square. Okay, you see here the domain will be R3, which means R, like infinity to infinity, and then your range is more than 0, but you have to know what is behind that. So you have to know what is the meaning of that. So that's why you have to use some tools that can help you. I know range is a little bit difficult than domain. Okay, domain need more example. Okay, so range 50, 50 range. Yeah, understand. You have any tips hack so that calculate within the range. For the range is you have to know what is the minimum and the maximum value, and then you have to find the whole value of the function. You have to see the whole as the whole value of the function. Okay, would you advise to do a lot of practice? Okay, yes. Domain identify ellipses parabola. Yes, you have to study this. Okay, please study about the ellipse parabola, because maybe next 2 weeks or next week we will move to chapter 1 part 2, which is sketching the 3D. The domain need more examples. Sketching domain, inventing the graph, difference between domain and range. Here is the blur. The best part, domain. Yeah, domain is easier than the range. Okay, some of you feel range is more easier. Okay, domain is more easier because we just see the restriction. Okay, domain and range. Okay, good. Okay, so we have done chapter 1 part 1. So then now we rest for a while. Then we go to chapter 2 part 1 first. Okay, after finish chapter 2 part 1 and chapter 2 part 2, I will go to chapter 1 part 2. Okay, so we rest for a while, 5 minutes. So any question?
Doctor,
Yes.
when you write the answer for domain and range, do you need to write the hint in the red box from the example?
Yes.
Okay. Thank you, Doctor.
Okay. Okay, so we rest for a while and then we come back. I will come back. chapter 2 part 1. Okay, so chapter 2 part 1 will be more easier. Is partial derivatives. We will introduce the partial derivative, first order notation, partial derivative as a slope, higher order, chain rule, composite, and implicit. So why use derivative? If one idea from the only one person, one idea. Okay, I didn't prepare any video, but it's okay. Do you know why we use derivative? Can anyone share? Okay, why we use derivative? Can anyone share?
To determine rate of change of quantity.
Yes, correct. So in real life, things are constantly changing. Okay, so we are interested in physical quantity change. So for the change, we have to use the derivative. For example, object velocity change over time. Okay, how that does the force acting on the object with a distance. So these changes are described mathematically by derivatives. So in English, maybe we say changes, but in maths, we use the word derivative. Okay. So we have ordinary derivative that is involve one independent variable. We have partial derivative that involve two independent variable. Okay. So we have one and two independent variable. Okay. Remember that. And then if you see here, for linear function, it is easy to get the rate of change, because in every point, the gradient are the same. So usually the changes will involve the gradient. The gradient means changes, but this is for linear. How about if the line is not straight? So in every point, each 2 point here, the gradient are different. So we cannot use dy dx. That's why here you have to use partial derivative. So to get the partial derivative, we have to apply the limit. Okay. Skip this. So definition for partial derivative, if you differentiate f with respect to x, so it means you are changed in x. So in this time, your y will be constant. So that's why we didn't change in anything in y. We didn't change any increment or decrement in y. So we are interest to x. That's why we change in x and divide by x. Here we have to put limit. So for function differentiate respect to y. Okay, remember this function we call z. Z, let's say we have z function of xy. If you differentiate this function respect to x, which means we are changing in x. If you differentiate respect to y, we are changing in y. But this time the x are constant. For this case, y is a constant. So the delta also denoted as increment, also denoted as delta. Okay, find fx and y using the definition. Okay, for this, okay, fx. So we write the formula first. Limit the x okay. Remember fx, x plus delta x, here must be delta x. Here also delta x approaches 0, automatic 0. Okay. here. So fx plus delta x means we have fxy 2x squared plus x plus 2x plus delta x plus x plus delta minus fxy. Fxy just copy. Should write. Just copy 2x squared over. So we have to solve the little part. So if you extend this, you will get 2x plus delta x squared x squared okay. So don't forget we have 2 here, so we have to put. So this 2x and this will be cancelled off. Okay. Then 2x delta x will remain. Delta x squared also will remain. This will be off. So what we have now, 2 times 2 will be 4x delta x plus 2x squared delta x squared delta x. Then we can divide everything. Okay, I forget. You have to put the limit. Okay. Remember, don't remove the limit until you substitute this delta x. Then you can, okay, you can simplify, you get 4x 2 delta x plus, then you can substitute delta x equals 0. So this is 0, you have 4x plus okay. So this is your answer. Okay. Actually, this is a simple way without doing this, but they ask you using the definition. So that's why I have to do the long process. But the easiest way is, you see here, if they ask you to differentiate respect to x, okay, remember on your mind, hold the y or treat the y as constant. So let's say this is 2x squared, so you get 4x, and xy will be x, because y is a constant, right? Sorry, y. Y is a constant, so you differentiate x will get 1, differentiate to x squared will get 4x. Differentiate y squared will be 0, because we treat the y as a constant. So we can directly get the answer. But if the question asks you to use the definition, you have to apply this limit and show all the steps. Okay, how about Fy? The same thing. So you have that 2x squared fxy 2x squared plus xy minus y squared. So if you differentiate directly f respect to y, fy means del f del y. Okay. Okay, fy means del f del y. Use del because this is partial differential equation. It is involving 2 independent variables. So when you differentiate respect to y, which means x is a constant, whole x formula. Whole x. So this will be 0. And here will be, when differentiate respect to y, you will get x. This is 2y. Okay, we try to use definition. For fy, del y approaches 0, x will be 10, y see that. Formula correct or not? Yeah, y plus del y, xy, del y equal to 0. Okay. So fxy delta y from here, so x is remain, right? So you just copy this. 2x squared is remain. But for y, we have to add y plus delta. Don't forget the bracket. Okay. So this remain. Don't forget to put limit. You have to put limit until latitude. Check. So what we left now? X delta squared over okay. Okay, now you have. Is there any wrong here? Try to check again. 2x squared 16. 2x squared plus xy minus y squared.
You forgot to put y squared.
Yeah. So okay. So I left here minus y squared, right? So y squared means y. Okay, I will do again. See this. Okay. So you can see here fy. Okay, I do again. Okay, fy limit delta y approaches 0. X is remain y. Okay, so f, this is the same. So f, substitute directly, fxy delta y is 2x squared plus x y plus delta y. Yeah, I forgot this. Y plus delta y squared. Just copy. Don't forget the bracket. If not, you will get a wrong answer. To expand this, you have to copy this. Don't forget to copy. Y delta y minus y 2y squared minus so don't forget to copy. Then 2x squared cancel, xy also cancel. So we have x delta y. So y squared will cancel here. It's 2y delta y. Y squared over delta y. So if you simplify this, you get x minus 2y minus delta y. So for limit delta y approaches 0, you get x minus 2y because you substitute 0 after you substitute, and then you can remove the limit after you substitute. Then you can write like this. Okay, the other way is you just, if you want to check, just check. If you differentiate this respect to y, x is a constant, so it will be automatic 0. So x is constant, which means y gone, x minus x y squared. Y squared will be minus 2y. So it's correct. Okay, any question?
Oh,
So this is wrong. Okay. Okay. Next. You have z equals to fxy. How to write differentiation of z equals to del over del x. Okay, not d anymore. D for differentiation with one independent variable. Del means you are differentiating function with two independent variables. But when you differentiate respect to x, you are focusing on x, your y will be constant. Or you can hold the y. When you differentiate respect to y, that is changed in y variable, your x is constant. So, okay. So get used to the notation del over del x z means del over del x f. Sometimes we let z equals to fxy so that it look easy. That's why if you differentiate z means you are differentiating the function xy. Okay. And then differentiate respect to z means del x fx. So we put here x. Same notation. Just want you to get used to it. Del is used for more independent variable, replacing the d. Yes, d for one independent variable. If you differentiate the z respect to y means del f over del y equals to del z del y, del same, all the same thing. Sometimes we use this because it is more simple. Small y, small f also, but the y is subscript. Yeah, it's the same. So differentiate x at this point, which means you have to differentiate first, and then you have to put the point given. Same. Differentiate respect to y at this point. So we can write like this. Okay? So don't get confused. So if I write for you, okay, let's say, okay, I just write again. Fx del f del x. Okay. Fy means del f del. Okay. If I put z equals to fxy, same also. If I put del z, same as fx, same as del z del y means fy. Just a notation. Just want to introduce the notation to you. Okay, remember back what you have learned in engineering mathematics 1. And differentiate constant will be 0, differentiate x to the power n have to bring downwards and then minus the power. Differentiate the, how you differentiate the epsilon, how you differentiate the ln, copy whatever inside ln here, and then differentiate the denominator, put in the denominator, put in numerator. Differentiate cos will get negative sign. So this everything you have to, how to differentiate hyperbolic. So please remember back. Okay. Okay. Find if fxy equals to this function, find this. Okay. Okay. So if fx cube y plus x squared y squared, what is del f del x? Or fx, same, subscript x, f subscript x. So remember, when you differentiate a function respect to x, the y will be constant. So this will be 3x squared, y will be whole, it will be 2x y. Okay, how about fy? Del f del y. Fy, this will be x cubed plus 2yx squared. Okay, because when you differentiate respect to y, the x will be 10. So you just act like, let's say you act this as 5. So how you differentiate 5y? 5y will be 5, right? So just copy the constant. When you differentiate respect to y, x is constant, right? You let this 5. So this will be 10y. So here we have to put 2yx because the x squared is 5. Okay, then they ask you fy at, this is x value, but always differentiate first and then substitute the value, which means your x is 1. Okay, any question? Can you understand how to differentiate the function of two variables? So this will be 3x squared, 2x. Okay, so any question? Okay.
Doctor, the number, the first one.
Okay. Wait for a while. 1 minus 2 will be minus 1, right? So this is correct. Okay, which one?
Then f over del x. Not clear.
Which one? This?
Yes.
The second one?
First one.
Del f del x. Is it? So when you differentiate respect to x, y is a constant. Y is a constant. So how you differentiate x cubed? 3 bring downwards and then you minus the power, right? Y will be remain same. For this, differentiate respect to x means you are changing the variable of x to x. Y is a constant. Understand? Who is that?
Hazim. Understood.
Huh? Hazim.
Yeah.
Okay, Hazim, can you understand?
Yes.
Okay, so other question? Any question? No.
Sir,
No,
Yeah.
for the carry equal.
Okay, carry the one. Yes.
Okay, for the question 2, to find the fs and fy, do we need to do the long calculation one or just directly?
Okay, if they said to you, let me check. Okay, this is by definition, by using definition. If they didn't say anything, don't waste time to do this. Okay, am I answering to you?
Yes, sir.
Okay, so you understand? I really want
Okay, understand, doctor. Thank you.
others?
Understand, doctor.
Okay, so we go further. Okay, so this is -1, not 1, -2. So please amend in your notes. Okay, find fx and fy. I think this should be easy, right? So let me call name. Muhammad Faid, are you there? Muhammad Faid? Oh, your phone. Okay, please find a way so that you can contact me. Okay, Muhammad Hassan.
Me, doctor.
Okay, can you do this? A for A.
Okay, let me do for us.
Okay. After you have done, please post in Padlet
Okay, sir.
and write your name. Okay.
Okay. So can I see the question again?
Yeah, okay. I think I will copy this to the Telegram. Okay, try to see the Telegram. A. Okay, another one will be Nur Ain Nabila. Are you there? Ain Nabila? Nurul Jannah? Are you there? Shall we?
Yes. Yes,
Okay,
doctor.
can you solve for B?
Sure.
Okay, after you've done, you just copy in one piece of paper and then you upload in the Padlet. Can.
Okay.
The question is in our Telegram.
Right.
So I have done. How to post it in?
Try open the Padlet
Hmm.
and then try to add plus here and then write your name.
The answer only or?
Yeah, you take picture and then upload. I think you try to write your name first like this. Let's say your name, you type your name. Okay, then you can click this snap.
Okay.
Hassan, is it? Or shall we? Who's it? Okay. Oh, you have done for both. Okay. Okay. We wait for Hassan. Hassan, are you okay?
Wait, sir, I'm trying to do it.
Okay, okay. Okay, thank you, Hassan. So let me do first, and later we check the answer. So if I do here, okay, so A will be fy for the following function, right? A fx will be dx squared y squared plus 2xy plus 4, and then there will be 0. Fy for A will be, in the function differentiate respect to y, will be 2yx cubed plus x cubed plus 4x will be 0 minus 5. So no need minus plus here. For B, fx is 2y4, sign will be cos x, they remain the same, and this will be 0. Fy will be 8y cubed sine x plus 0 minus 6ey. Check. So we see Hassan first. 3x squared y squared. 3x squared y squared, 2yx plus 4. Okay, Hassan, you need to remove this 5y.
Okay, sir. Okay.
Because if you differentiate respect to x, y will be constant. You treat this y as a constant, okay? Okay, for B,
Okay.
we check for B. Sorry, for second one, fy will be 2yx cubed, okay, correct? Plus x cubed, okay, again, you have to remove the 4x. Okay, it's okay, it's wrong now. Yeah, Sam, 4x not here, 5y.
Okay, thank you, Doctor.
Okay, then shall we? You see, shall we answer? 2y cubed cos x plus 7x. Okay, again, I think there no need 6ey, shall we? No need 6ey. Then
All right.
yes?
Okay, okay.
Then the second one will be no need.
Same.
Which
No
one? Which one no
EX.
need? Yeah.
EX.
Yeah. Why?
Because X becomes 0.
X is a constant.
Constant.
So 7ex is a constant. Let's say 5 or 1. So differentiate 1 will be 0.
0. Okay.
Sorry.
All right.
Okay, good. Okay, so yeah, second one. Okay, there's solution there. So see whether there is wrong or I'm afraid some typo there. X squared, 3x squared, y squared, and 4. Okay, this is okay, right. F5 will be 2x cubed, 2, okay. With respect to one. Okay, thinking is okay. So second, find fx01 if something like, okay, I will do for you, okay? fx01. Okay, for this question, you try to do fx first. Fx is 4x, 6x, I equal to 0 minus 1. Okay, so fx01 will be, which means your x 0, y is 1. 0 minus 0 minus 1. Okay, then fy, okay, what is fy? Be 0 minus 3x squared plus 2y. Y 0, 1 will be 0 plus 2, right? 0, 2. Okay. Okay, function of 3 variables, yeah, okay. For this course, the maximum variable will be 3, okay? Okay. Again, it's just the same, but we have z. Fx, when you differentiate f with respect to x, your y and z will hold constant. Treat y and z constant. When you differentiate respect to y, your x and z will be, when you differentiate respect to z, your y and x. Okay. So, say that I copy this. So we don't need to see the solution yet. So fx will be 2x plus 2y squared. Yz will be 0. With respect to y, x will be 0, will be 4xy plus z cube. Fz will be 0, 0, 3 yz. Okay. So we see back whether our is correct or not. Okay, any question for this? Anybody got any confusion? You can raise up your voice. Okay? Okay. Important to recall. Okay, you learn this for one independent variable, product rule, quotient rule, chain rule. So we will use this also in this chapter. Okay? Okay, see here. I'll copy this. Okay, find del f del x at 1, 1, or you can write as this. Same thing. So when you write this, they will put slash thing that just like want to say 1, 1. So or you can write like this. So this is the equation. So the main thing is you have to find the differentiation first, and then from the results of the differentiation, you have to put the value of x and y. So in here, if you expand, you have to expand 5xy. Then you have 3xy to the power of 5xy. Okay, now, if you see here, you have two functions here, polynomial, exponential, polynomial, exponential. So in each of the function, you have xy, and normal function also you have xy. For polynomial, you have xy. For exponential also, you have xy. So you have to consider both. Let's say you differentiate something that need two constant, then you have to do, say, x, e, x. So if you differentiate this respect to x, as you learn in engineering mathematics 1, you have to do product rule, correct? Copy left, differentiate right, plus copy right, differentiate left. Okay, same. If like this, differentiate this, you have to use the quotient rule. That is, copy the bottom, differentiate the top, minus copy the top, differentiate the bottom over. Okay, so you have to apply the same thing, but you have to bear mind which one is constant while differentiating. Let's say you differentiate respect to x. So y is constant because the function is multivariable. You have more than one independent variable. If you differentiate respect to y, you have to treat the x is constant. If you differentiate respect to x, z, x and y are x, z, x and y are constant if the function is 3 variable. But now the function is only 2 independent variable. So fx will be, you have to go 2y you can put outside, but you have to differentiate the square e to the power of plus 3y squared you can bring outward, and then you have to differentiate Okay. So differentiate this will be copy left, differentiate right. Differentiate this. When you differentiate the exponent, just copy the exponent and then differentiate the power with respect to x. Mean this is 5y plus copy left will be 2x. Okay. This also same. The power respect to x will be 5y plus whatever at the right, and the left will be 1. Then you can simplify this. 10y squared for 5y 4x power of 5y 3y squared 15. 5, right? 15y squared will be y cubed. X e to the power 5xy plus 3y squared e to the power 5xy. Okay. I want to simplify because my intention is to find 1, 1, right? 1, 1, then y. Sorry, x1, y1. So e5 plus 4 e5 plus 15 e5 plus 3 e5. Okay. 4 plus 10 plus 4, 14, 15, 29, 32. Okay. Yes, 32. Okay. Any question for this example? So I'll continue. Find del y if the function is ln x plus y. If the function is ln x plus y, differentiation with respect to y will be copy whatever inside the ln, put at the denominator, differentiate this with respect to y, this will be 0 and this is 1. Done. Easy. Okay, 1 over x plus y. Copy the inside ln to the denominator and differentiate the denominator. And then you can remove the ln. Okay. Okay, partial derivative as a slope. This you don't need to know so much. This also you don't need to know because it's not covered on the syllabus. It is just want to show that when you differentiate respect to x, so the x is the changing and y is a constant. So this is a graphical interpretation. While you differentiating respect to y, the x is constant. So they are moving here for each point. Because these are surface now. You cannot treat this as a line. It's a surface. Okay? Because we have 3D now, x, y, z. Find the slope of the line that is parallel to xz plane. Okay, remember, parallel to xz plane means y is a constant. Okay? And tangent to the surface. So tangent surface means you have to differentiate that at the point P1 to 3. So if the line is parallel to xz plane, y is constant. Y is a constant means you have to differentiate respect to x. This is the main thing. Easy. Okay? So what you have now, z equals to this. You can let this as xy. So to differentiate f with respect to x will be, this you have to do, I think I have to do x square root f x y is x square root x plus y. So if you differentiate respect to x means you have to do the product rule. So this is same as x plus y power of half. So copy whatever at the left, differentiate right, minus 1. So you just put here, differentiate inside, plus square root x plus y, 1. Over 2 square root plus y plus square root x. So but they ask you at the point 132. 132 2 will be 1 is x, 3 is y, z is 2, z is now here. So x 2 square root 1 is 4. This 1 over 2 times 2 is 4 plus 2. This is 2 means 804, right? Check. Okay, 904. Okay. So make sure you are good in differentiation, find differential hyperbolic function, any function, so that you can proceed to this partial derivative. Okay. Okay. Are you okay? Any question?
No.
Okay. Then we have more than one integral. Fx, Fy, we have learned. Fxy, you didn't learn yet. Fyx also, you didn't learn yet. So are continuous, defined in an open space, that is Fxy equals to Fyx. For your syllabus, we will consider the function is continuous. Okay, you don't need to check. So Fxy is always same as Fyx. So you might wonder what is that, right? So Fxy and Fyx. Fxy. What is that? So this is the first one, right? This is the second one. So this is same as del over del x del y. Yeah. No. Del x. It will be a y, here will be x. Okay. We have to differentiate respect to x first and then respect to y. That's why I have to put in the right hand side. Here is left, but here is right. Here is right, but here is left. F, x, y means you have to differentiate respect to x first. And then you have to differentiate respect to y, which means you have to differentiate respect to x first. I have to put on the right, but here is left, right. Here is left. The right one is del over del y, which means this is del squared f del y del x. Del times del squared, del y del x, we cannot do anything. So this means you have to differentiate respect to x first, which is this, and then differentiate respect to y, which is, maybe this is new to you, right? So f y x means you have to differentiate respect to y first. Put at the right hand side. Okay, make a space a little bit after the equal, and then the respect to x. Del, no need to put del f again. So del f will be square f, and this is del x del y. The difference is just we interchange this, but actually they are same. Okay, because for your syllabus, the f is a continuous. Understand? No. Understand not? Euler theorem.
Understand, Doctor?
Yes,
Okay,
sir.
good. Okay.
Excuse me, Doctor, can you repeat that one?
Which one? This. Which one? Who is
Yeah, this one.
Who are you?
I am Abdikafi Omar.
Again?
I am Abdikafi Omar.
Which one? Oh, Abdi Kafi Omar.
Yes.
Okay. So what do you want actually? You want me to
Repeat this part.
this one?
Yes.
Okay. So I repeat again. F x subscript xy. F subscript xy. We differentiate f with respect to x and y. Which you have now two independent variables. Which means in your mind you have del square f over, okay, if this is in the left, right, at the left, so which means you have to differentiate this first and then you have to differentiate this. So if you differentiate this, you have to put at the right hand side, and then you have to put this, because you will solve for this first. You will solve for this first, and then you can solve this. You will solve this. Same for f y x, you will solve for y first and then x, which means this is del squared f, del that will be y, and which means I can write like this. You will differentiate the function with respect to y, and then you will differentiate the answer of this with respect to x. I will give you an example so that you can understand. Okay, what if you have this? This is del square f over del x. It is just interchangeable. You can remember that if xy, yz, sorry, xz, zx. If yz, zy. Okay. Abdi Kafi Umar.
Yes, yeah.
Okay.
Sure, yes.
Okay. Okay, this will be a harder example. Here, f is this, where x, y not 0, show that hence they use this. Okay, this will be long solution, but see, I will try. Okay. So this is like proving question. Okay. Show that x del f del x and y del is to f. I think this is easy, right? Okay, let's say I start with left first. Left hand side, x fx. I can write like this, plus y fy is the same. F subscript x, y f subscript y. Then we have x is just copy. Fx, okay, your f is x squared y squared over x squared plus y squared. So your fx will be I have to do quotient rule because I have 2x now, x squared y squared plus y squared. It's 2x y. Sorry. I have to do quotient rule, right? So I have to be whatever at the bottom. Shit, at the top you get 2xy squared. Let's copy the top. Shit, the bottom respect to x. top minus coefficient. Okay. Fy will be the top will be 2 squared y, right? So if I plus do this, and I have to times with x, right? So when I times with x, 2x squared y. Put x here, x here. So this no need because it is times. Okay. Plus, sorry, minus. Two x squared. 2 squared times squared squared, which means 2x to the power 4, right? Check if I am wrong. Over okay, this will be long process. So see whether I can factorize anything. Okay. See here. I factorize 2x squared. Squared, right? So what we have here? Okay. Okay. I try to solve that first. See how. It's 2x to the power 4 y to the power 4 2 plus 2 to the power x power 2 y to the power 4 plus 2x power 4 y to the power 2 over x squared plus y squared. I think this can cancel. So what do you get now? 2x power 2 y power 4 over squared plus 5. So how about this? Okay, for this, I have to make y times y. So y here, y here. This is x squared y plus y cubed. Oh, we have another. Okay. 2x squared y is 2y squared. Y power 4, x power 2. Okay, this times. Okay, then we have x squared plus. So I think I can simplify this. X power 4, y power squared plus 2x power 2, y power 4, 2x power 2, y power 4. So this can be cancelled. We get 2 x power 4 y power 2 over x squared plus y squared squared. So now we have to plus, right? We have to plus. So what do you get? X f x, y f y. Take this. Here will be 2 squared y to the power 4 plus 2x power 4 y power 2 over a. Remove, try to bring the 2 a I to power of. See whether we can do something on this. 2 x squared. What do you get here? Y to power of 2. Right. What do you have? Of 2 plus x to power of 2. Well, squared plus y squared squared. So these are the same, right? They are the same. So you can cancel 1, 2 x squared y squared over squared plus y squared. So I think this is f, right? Try to see the f. Right? X squared y squared, x squared plus y squared. So this is 2f shown. Okay. Can you see? Can everyone see it? So I think this is one of the tedious work. Okay. Sure. Hence, we want to deduce this. I think this is one of the tedious part. So this, I will leave it to you. Try to do it. Can. So if you have any problem, just come back to me. Okay. You have to do 2 different things. Then you have to add, and you get the answer. So remember for your case, fxy same as fyx. Which means del square f del x del y will be the same as del square f del y del x. You can treat this as the same. Okay. And can you manage to get what you have learned today?
Yeah.
Everyone?
Yes,
Yeah. Okay. This I leave it to you. If you have a problem, just come back to me. So we see the last example.
Yeah.
Okay, this is the last example for today class. So we see this. Okay. Okay. Find the partial derivative. They give you z, okay, which is function of xy. You can write like this. So you no need to write also. So just, this is just notation, okay? Same as 7x cubed 5x squared y plus 6y. So find del squared z del x. Okay, as I mentioned to you, this means you have square, right? You mean del 2 times. It means del 2 times. So equals del z del y. You have to do this first. The right hand side. Okay. This is same as f y. Okay. You have to do y first, differentiate respect to y. So you can write like this as well. Z. Same. That's a notation. So differentiate this function respect to y first. This is for this del x del o del, just copy. Then you have to do whatever inside first. So respect to y will be, this is 0, this 5x squared, y is a constant, we remove. This is 18y squared. And then not finish yet. And then respect to x, negative is 0. Okay. Then they ask you to do del square z, del y, del x. So this is f x y. Means you have to differentiate respect to x. Sorry, respect to x first. Which means this is del over del x first, and then is opposite of this. Okay. So del z del x. You see del x is 21x squared. Copy this. 21 squared. Respect to this is minus 10x. 0. Okay. Oh, respect to y. So this is 18 6y cubed, right? Oh yeah, I'm doing wrong, I think. When you differentiate this z respect to y, this is 0. Right? Respect to y first. So I get confused. When you differentiate respect to y, this will be 0. This will be negative 10 x. Sorry. This will be negative 5 x squared. And then this will be 18y squared. Because you are now differentiating respect to y first. So you have to, when you differentiate respect to y, x is a constant. This will be 0. This we have negative 5x squared. This is 18y squared. Then when you differentiate this respect to x, then you get negative 10x. This is 0. Okay. So for this case, when you differentiate z respect to x is 21x squared. Then this will be negative 10xy, and this will be 0. So when you differentiate respect to y, this will be gone. Then you get negative 10x. So they are the same. This is proof that fxy same as fyz. Or you can write as zxy same as zyx. Okay? Can you? These two have the same answer. Okay? So keeping the y fixed, differentiate respect to x. Then keeping the x fixed, differentiate respect to y. Okay. Differentiate inside one first, the right hand side one first. Then differentiate at the left. Okay. Then number 3. Del squared z del x. Okay. Del squared z del x squared, which means you have to differentiate the function z 2 times. Del squared z over del squared same as del times del z over del x del x. This will be del over del x. So differentiate z respect to x is 21x squared. And this is negative 10xy. Differentiate again respect to x, 42x minus 10y. Done. Okay. Last one, fxy add to 1. fxy add to 1. Same as del squared f del y del x add 1 to 1. So we have done, right? We've done. This is negative 10x. You have to differentiate. You get negative 10x. So we just substitute negative 10 times 2 is negative 10. Okay? Okay. Any question? Any question?
No, doctor.
Are you okay? See, is there any wrong there? I check here. Is at 21x squared, then x, 42x. Okay, so this is 42x minus 10y. Something wrong here? Oh, it's 42x time, correct. So are you okay? You want to stop? Or are you okay?
Good.
Okay, doctor.
Okay, so we will continue in next class about the chain rule. This is a different thing. Okay, so I will give you this recording and I will give you this slide and also the Microsoft OneNote. Okay, see you in next class. Have a nice day.
Thank you, doctor.
Thank you, doctor.
Yeah.